So hopefully you read this question in advance. There is no new lesson today. We're just going to go through a couple of midterm exam strategies for next year with one example, and then two questions you're going to work on your own, but I'm going to give you some hints ahead of time. So this first question, I hope you read it. If you didn't read it, pause the video right now, read this question, and kind of think about it. Now, for those of you that did read it, what a pain in the butt this question is. And I see this question all the time. It's in every textbook, and it's in every single midterm exam in university that has to do with electric field. They give you the radius of this ring. They tell you the entire ring has a charge of. And they give you it doesn't even matter what value they give. They give you a value of the charge of the entire ring, and they say it's evenly distributed all the way around the ring. And they want to know what the electric field is at the origin, at the center. So, you can't even draw a Q on here because the entire ring has one giant total charge. But let's think like calculus. Let's think like Newton's mathematical theory where you divide things into tiny, tiny, tiny little parts. Imagine this ring is divided into all kinds of numerous little equal intervals all the way around the entire ring. In fact, you see how they have these plus charges drawn all the way around the ring? Let's pretend that there's an actual spot at each one of those axes, even though there isn't. I just want to show you how this question works and how easy it is. So, yeah, okay, I put these dots at these axes, but imagine 1,000,000 of these dots all the way around the ring, or even 1,000,000,000 of these dots all the way around the ring. Every single one of those little pieces, those little tiny slices of the ring, would have the same amount of charge because it's evenly distributed all the way around the entire ring. Well, if you did a calculation for each one of these tiny little segments, and you could, because they're asking for this, they're asking for the net electric field at the very center. So you could do a calculation for just this charge. And you could say, okay, so this little tiny positive piece, we draw field lines away from positive charges. So at the center, there's going to be a little tiny electric field from that piece. And you could calculate that electric field if you knew how much of the charge to use, but let's not even do it. The point is, you could have some part of the charge, you have a distance, and you have your K value, which never changes. You could calculate that little piece, but guess what? As soon as you get to the other side of the ring, there would be another little piece directly opposite it that would have exactly the same effect at the center and the same electric field in an equal and opposite direction. And those two would cancel each other out. And if you think about it, that same pattern happens all the way around the ring. It doesn't matter how you distribute the charge or how many dots you want to draw. Every single one of these little dots would have an electric field going one way and a corresponding dot on the other side with an electric field going the other way. So it's very confusing on your exams next year because they're going to give you these values. They're going to tell you what the charge is. They're going to tell you what the radius is. And even if you get this on an online assignment next year, every person that logs in is going to have randomly generated values for the radius and the total charge. And the answer to the entire question is 0. Nothing. That's a 0. That's not a circle. Maybe I should have wrote it like this. Net electric charge is 0 newtons per coulomb at the center. Everything cancels out. That's the symmetric nature of the ring. That's going to be tough. When you have online assignments and you know that every time you enter a value and hit send, your mark goes down a little bit if you get it wrong, you're going to be so leery about entering 0 and hitting enter just because it's going to seem way too easy. But that's the question. So you're going to work on 2 problems. And one thing that I have to warn you about right away with electric field, and this happened with electric force too, with Coulomb's law, they love to draw diagrams. They love to give you diagrams because in their mind they think they're making it simpler for you because they're setting it up. And your first impression when you flip to a midterm exam question and it's got a diagram, is it's stressful. You're going to see the diagram first, and you're going to look at it and say, oh my God, I've never done anything like this. And you're immediately psychologically going to say to yourself, it's going to be really hard. And when you're expecting something to be difficult, your brain makes it more difficult. You have to free yourself up from that. And the other thing about this question is there's no numbers. The entire thing is letters. Actually, I see a 4 there. But I mean, the entire question is algebraic. And you got to get over that hump too. Because next year numbers are going to disappear so fast and everything is going to be algebraic. And you got to get over that hump where you just do it. You did this question already. You did a question like this on the homework that you just took up before this lesson. There are 2 charges. There's a point between them. They labeled it as an A this time for some reason, but whatever. Little point in space between the 2 charges. And they give you the distance. Everything you need is here in terms of distance, even though there aren't any numbers. If you knew what the value for L was, this would be L divided by 4. So everything's fine. And it also tells you that the electric field at point A is 0. You did this question. It was actually question number 3 on the work that you took up just before this lesson. This is a negative charge, and negative charges tend to have field lines drawn toward them. So at point A, Q1 will have a field line drawn toward it, and point number 2, which is also negative, has field lines drawn toward it. So at point A, it too will have a field line drawn toward it. And they tell you, you don't even have to deal with any kind of a net field here because the net field is 0. So that makes this question very, very simple. That means that electric field 2 and electric field 1 are equal to one another. And that's how you start the question off. Start it off literally with electric field 1 must equal electric field 2. You have a formula for electric field, so fill in the left-hand side and the right-hand side. And instead of filling in numbers, fill in these variables that are found throughout the question. And you're going to get a lot of cancellation, left side, right side. There's nothing to really solve for. They're not telling you a specific thing. So they do something really weird here. They say solve for the ratio Q1, Q2. In other words, when you substitute things in and you begin canceling things out, rearrange your formula, whatever it becomes, rearrange it so that you have that, so that you have Q1 over Q2 equals what? What's on the right-hand side when you rearrange Q1 over Q2? Try it out and see how easy the question is. The second question you're going to work on is actually very much like that ring question. Sorry for the hard to see ink on here. My printer's running out of color and I'm starting to get yellows for any other color on the screen. Take that ring question from the beginning. What if you chop half of it off? So now you don't have that symmetry. But it's not, this question isn't a complete ring like that example was. It's literally these charges. 1, 2, 3, 4, 5 charges are arranged along the edge of an imaginary circle. And it wants you to calculate the electric field right here. What's the net electric field right there? Again, diagrams. This looks scary. If you had never done a question like this next year and you walked into the midterm exam and saw that, that would scare the heck out of you. You'd get all stressed out and things would start to fall apart. However, this is an easy question. The charges are all plus 7.5. They're all plus charges. That means each one of these charges, and it's a little confusing on this diagram because they drew the charges as dots instead of like circles with signs in them, but those are charges. This is your point P, or whatever you want to call it. Each one of these charges is a positive charge and has field lines drawn away from it. So charge number 1, field lines all drawn away from it. At point P, there will be a field line drawn away from it. And you can figure out the value for electric field 1 in this question because there's actually numbers provided for this question. So calculate the value for that with the little formula. none of the values change. It's the same distance because it's a circle. So the radius is the same to each one of the charges, and the value on each one of the charges is the same. So you will get the same electric field value repeated 5 times. And every single time it will be drawn away from the charge in question. So in the end, you end up with a diagram that's going to look something like this. Every one of these charges has the same arrow. In the end, you have to come up with a net electric field. There are 5 electric fields, and they have those exact angles shown there on the diagram. How do you put those together and get one final answer? You got to think vectors. You got to think vectors. You got to think canceling vectors, vectors on angles, break them into components if they're on angles, cancel vectors, etc., etc. I want you to come up with a final answer to this question, and there is a final answer to the question. And we'll take both of these up and see if you get the answer. I'm going to leave you with just that diagram, but you have to put those 5 vectors together. And think about what we've done throughout this course. Vectors on angles, break them into components, and then add and subtract things up, down, left, right. What do you get in the end when you put this together?